Our next speaker is Thierry Fautier, who's already right here.
Hello everyone, I'm Thierry Fautier, the one who's keeping you away from your 6 p.m. drink. So, before you guys start to talk and think about drinking, I want to talk about a serious topic, which is how OTT service can match the quality of broadcast. And because it's a complicated topic, remember last year I was talking about codec and I come with my paper, I did the same thing. I wrote a paper on NAB, presented also at SIMT in LA, presented in Australia, so SVA also enabled me to present my view. So this is, you'll see an introduction of the topic. What are the techniques we are developing in the space to make the content easier to stream? Content-aware encoding is one of them. Low latency, you will hear a lot tomorrow, so before you get swamped, I will give you a quick tour of what is happening in the space. You heard about cloud, and I want to show you how cloud can help you to deploy service at scale very quickly. And then the last topic is the network optimization, and you will hear some new concepts which are all for some companies, and I don't want to skip the Netflix benchmark. How many Netflix people do we have in the room? They're gone already? You see, anyway, so I will present what Netflix is doing because we believe that Netflix is a very strong position in the streaming space, and of course some conclusions. So first, you probably have heard of those events in 2018. So you had the golf tournament, the F1 service, and in France tried to launch for a few 100K subscribers an OTT service. They all failed. And you will understand first, these has serious damages on the brands. Consumers are frustrated, and this is all bad for our industry. But in order to understand, you need to also understand what happens. So for those who don't know, you have the first process, which is the sign up. Sign up is you register yourself. Sign in, once you are signed up, you come to the service and you try to connect. And then there is the consumption. And I can tell you many services fail either on sign up or on sign in. And of course, some cannot sustain the load. So at the end of the day, you get bad press, social networks, pirated site, people cancel service, asking for refund. So at the end of the day, this is a serious issue. We need to understand first, acknowledge, and work on it. So the scope of this presentation is basically looking at how OTT can scale. And obviously, broadcast is easy to scale. Took some time, but now we know how to send the same signal to millions of subscribers. We think that Netflix is today the yardstick in terms of scalability. 58 million in the United States, it's a lot of streamings. Is there a way that live OTT can match those quality of experience? And we will focus here on delivery and consumption. I will not talk about open caching, multicast ABR, and peer-to-peer, since either you got a presentation today or you have already seen that presented before. So very important, people talk about OTT, and I hate to hear OTT, especially when it's a case of managed ABR transmission on an operator's network. And OTT is definitely unmanaged transmission over unmanaged network. So you can see the quality of service is different. The gateway is managed by the operator, one unmanaged by an OTT service. And you see that operators, most of the time, bring their own device, or sometimes you see operator and bring your device in the case of OTT. So different system environment, and of course, you will see a different quality of experience. So in terms of network topology, you have on the top, from the same head-end content going to a managed network, going to an operator set-top box. That's what we call the managed ABR. And on the bottom, you have the public internet for like service like Hulu or Netflix. And then you have two types of architecture. Either it's a bring your own device. In that case, the OTT provider will put his app on this device. or it's an OTT on an operator set-top box, and in that case, it could be run on the operator set-top box. This is the case of Netflix running on operator set-top box. So different system architecture, and you'll see different performance. So OTT, you have the head-end. Most of the OTT providers today are using content-aware encoding, and you will see that in a coming slide. Origin server, you know that it scales up and down depending on the traffic. You have to go at a lower bit rate. CDN is the best effort. It's a third-party CDN. Gateway is the best effort behavior. And of course, you can have bring your own device or operator, most of the time on a Wi-Fi connectivity in a completely uncontrolled environment. So as you can expect, this type of architecture has several points of failure in terms of scalability. If you look at what we call IPTV 2.0, basically all ABR delivered across a managed ISP network in unicast. You have ABR head-end, most of the time still encoded in an old-fashioned way. You have an origin server. You have a CDN, which is guaranteed quality of service as it is a managed network, and sometimes operator brings his own caches on his own network. The gateway has a quality of service because it's managed by the operator, and the set-top box most of the time is connected in a wired way to the gateway. So if you look at this architecture versus that architecture, So if you look at this architecture versus that architecture, we have an example of a customer who has his content running on his own network versus an OTT network, and there is a 300% difference in terms of quality of experience measured on his own KPI, which is buffering, delay, startup time, and all kind of KPI he has put. So which means that you have to look at OTT in a different way when it's an OTT service or a managed service on ISP network. Let's look at content-aware encoding. So you probably have seen Netflix and YouTube either doing title or per chunk-based encoding on the VOD traffic, VOD service. And then you can have that also at the frame level, and this is what companies like Harmonic are doing today for their live service. And at the end of the day, it's the same technique, open loop VBR, in-loop psycho-visual modeling, and machine learning, as you could hear in the morning. And basically, if you want to compete with Netflix, one advice I would like to give you is you'd better use the same weapons on the same line. If the subscriber has a great Netflix experience, and if your OTT service looks poor, I can predict you will not keep this subscriber for very long. So the way it works is basically you have your compression engine, which is making real-time assessment of the video complexity and is giving more or less bits depending on the video complexity. Oops, sorry. Oops. So we have developed this technology in Harmonic. We call that EyeQ. It's a content-aware technology. It's up to 50% saving. It's a constant video quality versus a constant bit rate. It's 100% standard compliant because it's iOS 11, and it can work up to UHD, and we got multiple awards for that, so we're quite happy with the results. So here you see some numbers, and it may be a bit small, but you see the red is the buffering on the classical CBR encoding, and the blue line is the ratio of buffering when you apply content-aware encoding. This was on the 4G network. We tried to push HD content, and you can see on this typical use case, we could measure 4 times less buffering, more HD profile. You see the blue are higher on the high resolution on the second one on the bottom. And you see the startup time, similar startup time, and much less oscillation. So this gives you an example of how content-aware encoding can bring you a much better quality of experience. This is just due to the fact that the number of bits to transport is just half compared to the classical CBR approach. So low latency, you probably will see a lot this type of chart what was the Super Bowl measured buffer delay between 30 and 45 seconds, and the broadcast, I put the red line, broadcast delay was about 5 seconds, which means that a lot of people were frustrated to hear the result from the neighbors, to see the social network, so I will not go too far. The way it works is in a classical approach, you have to buffer segments after segments. In the CMAF dash approach, you are buffering 200 milliseconds from one element to the other with micro chunk, and at the end of the day, you use, of course, a MPEG-based solution that is cacheable on all CDN because it's an HTTP approach. And those are the results we have measured last year across multiple head-end configuration, on-premise, in the cloud, managed or unmanaged on CDN, Akamai CDN, wired wireless. So it was between 5.5 and 9.5 seconds. So you can see that in some cases we can reach the delay of the broadcast system. In others we can't, but we also need to say that this is an encoder which is not optimized for low latency. It's optimized for high quality. So still a 6 to 9x improvement compared to the deployed services. So let's look at how cloud can help us to scale. And I want to share with you an example of a deployment we have done with a SaaS platform. So this operator is called Telkomsel. He has just 193 million subs in Indonesia. In 4 weeks, we could deploy a complete service, which was the World Cup. And we could ramp up to 4 million subs, having 550K simultaneous sessions at the same time, and this was using our content-aware encoding together with Axido and CasLab. Of course, this is nothing compared to the 18 million session that Akamai can stream, but this was a very fast project. We didn't have to plan a year in advance. It was something we could do in very few weeks, and you'll see why this was a success. So basically, what we provide here to the operator is a complete service of ingest, transmit, and then we push all the content in the public cloud. This is AWS, where we transcode, package, encrypt, and origin to Akamai servers, and then we have all the backend by Axido and CasLab. So this is a trend we see more and more. Content provider, service provider who want to launch a service for a specific event. They do not want to buy CapEx. They do not want to train teams for one event. And if it doesn't fly, if it doesn't work, they do not want to pay for the next event. So here it gives you an idea of how much traffic we had to carry. And you see from the lowest to the highest number of viewers, we have a 10x. So here, definitely the CDN is key, but all the infrastructure, especially the origin server, has to be able to scale accordingly. So take away 6 weeks from the start to the streaming of millions of sessions. For the customer, this was a success because he could deliver something that he was not able to do with his own team. So we also proved that we could scale up to 4 million subs in 30 days. And of course, this is a pay-as-you-grow model. So we think the cloud is the only technology to deal with such an unpredictable traffic. So let's look at the network optimization. So basically, you probably have seen that picture before: compression, packaging, CDN, network client, all of them reporting some kind of analytics with a spec, which is, of course, all depending on each vendor. Out of this, you create a beautiful analytics database that you put in a dashboard and that you show to your marketing every month. And the joke we're making, this is a log file to nowhere, meaning out of this, you cannot act. You cannot decide what to do with those data, especially if you have a surge in the traffic. So for those who live in the US, you're probably aware that there's a lot of zero rating activities between the mobile operators and between the OTT providers and the mobile operators. Basically, there's an agreement where the OTT provider like Netflix can deliver its traffic without counting the traffic, and in exchange, the mobile operator is going to cap the traffic to low bit rates such as 1.5 megabits per second. So it's a win-win because OTT providers can deliver more content, mobile operator doesn't need to build any more infrastructure, and the consumer is happy because he's not charged for more consumption. And this is, of course, massively deployed. All mobile operators in the US have deployed this solution. So this is the bright side. Now, the dark side, if you look at the overall video experience measured by OpenSignal, which is an independent entity, you see that US is at the level of third world countries, I think, between Thailand and Bangladesh. And the reason is very simple. Because you cap the traffic, you offer always a very low quality of experience to the consumer. So how can we fix that? This was supposed to be removed, but maybe it's going to win, so I don't know. So it's a bet. I put a bet. So what we've decided to look at is how to close this loop. You remember the dashboard going to a log file, and this time we have taken the challenge to look at how we could build the network operation and policies, taking information from all the analysis we get from the database, which is the data part. The control part will go to a network optimizer, and this network optimizer will be able to touch three things: the CDN, edge cache, the origin, and the compression. So compression is quite easy. If you see there is a major surge on your network, you can always bring the bitrate down or remove some profile at the head end. You can decide to do some form of playlist manipulation either on the origin or on the CDN, which means basically dynamically bringing lower profile, and the challenge is not to do that once every day, but to do that once every chunk. So it's basically a real-time process. You need to do all this loop between acquisition, decision, and commands in real time every 2, 6, or 10 seconds. So if you look at the zero rating picture I was showing you, what we have in mind here is that, for example, when you have the RAN information coming from the mobile operator, you go to a traffic monitoring system, policy manager, and then in real time, the mobile operator could communicate to the OTT provider and tell him, okay, this is what we measure. We have to take that decision either ourselves as a mobile operator, or you do it yourself as an OTT provider in your client. So this would be a collaborative approach between the mobile operator and the OTT provider via API, and of course I put a spec question mark because I don't think we have this API yet. Basically it's a playlist manipulation if this is done by the mobile operator, and the good news is that ETSI, MEC, and potentially organizations like SVA could standardize, since now we are entering the 5G area. In 5G, you know that it will be much more easier to have access to API as opposed to 4G, where everything is vendor specific. So we think this would be a dynamic way to regulate the traffic from the measurement on the network to the service provider, mobile or OTT provider. So let me show you what we see happening today. So first, Netflix, as you know, per title encoding, already implemented origin server. They have decided with OpenConnect to bring their own caches in the ISP point of presence. They do not touch the gateway because they don't control the service, and they use their own application on bring your own device. So we think, so far, Netflix has the best quality of experience. And this one is probably the most important slide. I see people taking pictures where I've taken all the different technologies, content-aware encoding, codec, CMAF low latency, deep caching, CDN switching, traffic prioritization, client acceleration, network optimization, and you see for each category where current OTT service stand, where we think Netflix stand, and where we think operators should be to be at least on par with Netflix traffic. So as you can see, there is some serious gaps, which means there is some progression margin to bring superior OTT quality of experience for live. And I often hear people tell me, oh, but Netflix is a VOD, it's easy. When you know HTTP streaming, when you stream out of an origin server, live or VOD, there's not much differences. So I do not take the question. I will not take the question. So to conclude, OTT is still in infancy with regard to quality of experience. Difference between managed and unmanaged service can be huge. Quality of experience is improved today with CMAF and content-aware encoding. Cloud can help to scale fast. Network optimization, we think, is the next big thing happening. And of course, we need industry collaboration. That's why I give a pointer to SVA, which we believe would be the best place. Where's Jason? Jason is not at the bar. Perfect. Where SVA could be the best place to define the footprint, to work on API in order to orchestrate this big machine and hopefully make streaming great again. So I have 12 minutes for questions.
Yep. Until November 2020 to make it great again.
We have to wait, of course. When?
Thank you. If you go back to your slide, the one that you had, the comparison table.
Yes.
Yeah, this one. What do you mean by client acceleration? I may have missed that.
Yes. So client acceleration is basically a technique where the client is not fetching only one chunk, but is also fetching from higher profile or lower profile. And on top of it, is using specific TCP acceleration techniques. So if you read the paper, it's a bit more described. That's quite technical, but for those who know about those techniques, so there are companies like Giraffic, for example, well known for having a very strong position in client acceleration technique. And here you can raise the bit rate, increase the bit rate at which you fetch the video.
Thank you.
Thank you. I was waiting.
Not complicated question. You always compare between live and non-live. This is totally different use cases. People really expect the same quality of experience between live and non-live.
Why not? As a consumer, I watch Netflix, I see no buffering. I take a live service, I see macro blocks, buffering, skip frames. As a consumer, I'm not talking about the technology behind.
No, so I was talking about the technology behind. You should treat them differently because they are consuming different amount of resources. So the comparison is not fair. It's not fair to compare Netflix. They don't have all the problems of live. I think it's fair. This is what, if you don't agree with that, you will lose subscribers, because at the end what counts is the person who pays for the service. They don't understand the details. Like for example, content-aware encoding, everybody can do it on VOD. You take the input, you take the decision, and you make the best decision. To do it live is starting to be more complicated. To change resolution in real time in your manifest, you might break half of the client. To do playlist manipulation with a client who doesn't reload the manifest, he will never understand what you do. So there are specific steps
we believe people have to take. I have this right column to say this is where you need to look at. And I like I think we had the people of Stars who were saying, marketing guy was saying to the engineer, check the last column, this is what you need to work on. I think that was the best compliment, but that's my personal view. Maybe I'm a bit pushing over the top. We should not be complacent. Ask the people who have millions of subs. They are very humble.
There are no more questions, so one last round of applause for the day.